So here, guys, today we'll discuss here. It's kind of our first class of networking. So, so that is the reason we'll discuss first introduction of networking and so what is the difference between networking as well as network? What is the difference between networking versus network? So then we'll move to the devices here in between. Meanwhile, we'll discuss the OSI model. So that which layer, which devices are work, like router. Here we are having the router and switch, and we have a repeater hub like, and we have a firewall. Those are the network devices. Firewall, where we'll use these kind of devices and what is the reason and the requirement of the devices. Meanwhile, we'll discuss the difference between OSI model and TCP IP model. So both are the same. It's OSI model is a reference model and TCP IP model is the implementation model. So meanwhile, we'll discuss here majorly we have a 7 layers and here we have 4 layers. So end of the session, you will get the entire thing. So this is the topics today we have. So first, what is a network? Before that, what is a network and uses of network? So, so basically, network is a connection of multiple devices which is connected via any medium. So in between, we can use any medium in between we can use. So like we have wire media or wireless media, wireless also. So wire media means whichever we are using the devices like network devices, routers, switches, and whichever we are using the firewalls. So, and wireless media means in your home also we are using some broadband routers, and those we call it as a access points also. AP, AP means access points. Those are the media through connect the devices which we can communicate with different devices. The source is here majorly, the source is here. The source is here medium. Through medium, we are connecting the devices. Like the best way I'll explain. So here we have a PC or it's a switch or you can assume anything. So here in a between, we need a communication through these two PCs. PC1 wants to communicate PC2. So we need as a medium in between. So that is, we call it as a network. So again, now move to the networking. What is the networking? So basically, the networking is a sum of devices and equipments on the process of sending data from one end to another end. So here we'll use like a, guys, my screen is visible, right? Properly?
Yes.
Yes,
Great. Thank you for confirmation. So here now we'll discuss networking. So what is networking? So mostly we are using some protocols and some softwares and all where we are using those things at our in networking. So you can read it with with the use of some devices and equipments. Just now I have explained routers, switches, those things. With that help, will process the sending the data from one end to another end. We are sending data with using the devices, equipments. like firewalls. Not only the firewall, it's not only the device. Okay, it's kind of software also. In your PCs, firewall software is available. Okay, those are the data whichever we are using, the virtual data also. Virtually we are using, and we are using the devices as well as equipment also. So with that help, we are denying or permitting the information. So this is, we are permitting information. If you want to block in between, yes, we can block it. So with the help of networking only. But network, it means through media, the data is transferring. The main difference in between. And for that, so mostly the connection in between, mostly we'll use like here. So I'll give a overview something here. Here we have a two branches, and these two branches connected via. So these all are the PCs, host, end users. These end users are connected likewise, and this end users connected one access switch, and this access switch is connected any router, and this router is connected ISP, internet service provider, and this ISP again connected one router, and this router is connected again access switch. This is a switch. So this one is the ISP. So this entire thing we call it as a LAN, local area network, and this entire thing we'll call it as a LAN. This is, it's available in one location only. It's kind of your organization, it's kind of small office, it's kind of small office, or it's kind of home office. Soho, you call it as a Soho, small office or a home office, because here in this small office, mostly the 25 users are less than this, less than the 25 users are working. So this network we call it as a simple network. So the users maybe have some website. That website is different location. So that website is available again at one server, any server, GoDaddy. Let's assume GoDaddy. This GoDaddy is a GoDaddy. It's kind of public hosted websites. So they host their website in this GoDaddy. They can access entire thing. This is kind of small office. So they're not required anything much more devices and all. Just they can access. But if you have a big kind of office, so multiple users, and you have a own deployment setup, entire thing, so that time we need a entire concept of networking. So we need our own routers, we need our own routers, and we need our own switches, we need entire things, servers, we need our own servers. This entire setup we need. So for that we need one data center. So mostly will work in this kind of organizations only. So for this small office, not required network engineers. So where we are working, so this kind of big kind of organizations only we are working. So meanwhile, we'll discuss likewise. Okay, this is the LAN network, and this one is the another LAN network. This LAN wants to communicate another LAN. So here, forget about the Soho office, small kind of office. It's a Soho office, forget about it. Now we'll move. It's big size of our office. So we have entire setup. So for that, how we will establish the network connectivity in between. Meanwhile, we'll discuss point to point. So for that, we need a LAN and WAN connectivity. How we will establish, we have to know. So for that, I'll explain you small hierarchical design. Hierarchical design. Meanwhile, we'll discuss here our OSI model and TCP IP model. And in between, we'll discuss the devices also, which devices and what is the use of those devices. So hierarchical design, we'll discuss three-tier architecture and two-tier architecture we have. And networking, we have a three-tier architecture and we have two-tier architecture. Two-tier architecture. So, so for that, I'm taking here only one office. So for that, so some end users are connected here. So these all are the end users. And end user top of we have a access switches. These are the access switches. And access switches are connected. Any distribution switches. And distribution switches are connected. Core switches. These are the core switches or core routers you can assume likewise. And core devices connected to ISP. And ISP to connected to different branches. So there only we have a data center setup. You can assume this is our data center setup, entire thing. And so for that, so connectivity in between likewise, it's core, core switches, core layer, it's a core layer, and this one is the distribution layer. So what is the use of distribution and access switch, access layer? First, we'll discuss something, then we'll move later on. So meanwhile, we'll discuss the devices also, which devices where we are using. And these are the end user, host, PCs under PC. PC means we are users, whichever we are using. So it might be your PC or it may be server. It might be your landline phone, mobile phone, or access point, anything it comes under these things. So connected via, so the hierarchical design is important, guys. So these are the server. Server also comes under host only. And what is the use of core devices and what is the use of distribution layer and what is the use of access layer. So mostly here, this entire setup, we call it as a LAN actually. This entire setup, we call it as a LAN setup. Local area network, LAN setup. So LAN, apart from that, it will be moved to different location whenever we are reaching the different location. This is your data center, and data center we will use mostly two-tier architecture only. In between core and access which is only available, because distribution is not required much more. And if it is required also, no issue, we can take it as a in between the redundancy part. Yes, we if this kind of small setup, and we can use span and leaf architecture. We call it as nothing but span and leaf also. So here we'll use mostly core and it's kind of access switches. This is a span we call, and this one is a leaf. Span and leaf called, we call it as. Otherwise, you can use the three-tier architecture, same whichever we are using, core distribution. But in between core and core 2, here we have a distribution, and distribution, it is mainly for the redundancy. I'll explain the entire thing step by step. And this is the access layer, and access layer apart after, then we have here servers. Mostly what will be happen in data center? Servers only. These all are the servers, multiple servers we have. So multiple branches. This is the only one branch I have taken the example. Not only branch one, we have the multiple branches also. You can assume likewise. This is the entire data center will comes back. So first, in this branch setup, how the data will flow, we'll discuss now. So PCs and all you know very well, and above we have a access switches. This access switches mostly 2000 series switches we'll use, and this access switches will be manageable and unmanageable. You can use it, no issue on that, because if you are creating the VLANs and all in the top of distribution layer, you can use here only for extension level. You know the hub very well. I think hub, it's kind of don't call it as a dump device. Someone told you like dump device. If you are same word you are using in interviewer in front of, then he'll deny you. So it's kind of extension device. It's kind of extension box. In your home, you're using extension box like same like it is. We cannot manage anything. Just we can extend the network flow. Just we can extend our network flow. So likewise, otherwise, if you are taking the above more than these devices, like if you are using 29 series of devices or 24 25, those kind of devices, it will be manageable switches. So we can create in this manageable switches access ports. Will consider these ports as a access ports. Access port means it will be carry the single VLAN information. Don't worry, we'll discuss later on, but I'm explaining the hierarchical design only. So here, this is an access layer. Access switch means only one port is connected to one device. One port is connected to one device. One port is connected to one device. This is a PC is connected one device. And this all the access switches will create only VLANs, virtual local area networks. It's a layer 2 protocol. And in distribution to access layer will create a trunk ports, and apart from that will create here will run layer 3 protocols in between core to distribution. Will configure layer 3 protocols. Now this is the architecture, and in between we'll use the switches. And switches, it's kind of broadcast domains, broadcast devices. It will be send the broadcast information. So this is a network hierarchy. So now we'll discuss what is switch. So switch, it's a switch. So switch is now forget about the top of this. First we'll discuss the switches, what it will be do, then we'll move on later on. So switch is connected again, multiple PCs. You can assume this is the access switch. Access switch is connected multiple devices. So what it will be do? So here we have a concept broadcast, unicast, and multicast. The communication is happen in networking, not only the one way. The ways it will be defined, the whichever we are using the communication way. So for that we have a three types of communication happen. First, unicast, uni, unicast. It's kind of one to one. The communication is unicast means one to one. And this is the communications and networking we have. And one more is broadcast. Before that, multicast. We have multicast. So it's a one to group. It's a 1-2 group and broad. It's 1-2 all. So it's a 1-to-1. The communication happen in between one device to one device. So, and here we have a communication 1-to group of members. 1-to multicast means 1-to group of, and broadcast means 1-to all. The communication happen in networking likewise. So meanwhile we'll discuss. So 1-to-1 means the PC1 is sending some information PC2. So only switch is replying to this PC only. That is unicast. And whenever we are creating some VLANs, so we have a IP address is multicast group, class D group. Class D group, we have a class D group also. Later on we'll discuss. That is 1-to group. It will be send entire group. It's kind of, if you are announcing it 1-to-1. So in your college, you can assume likewise, you are announcing one student has headmaster is informing tomorrow leave, you don't come to college. So 1-to-1 hipping. So otherwise he went one class and he told to entire that class only 10th class event or any standard event and inform to them tomorrow leave, don't come college. So otherwise he announced in mic to everyone. So that is broadcast 1-to all, everyone can listen it in the entire college. He explained tomorrow leave, don't come. Likewise, this is the way. So now move to, so here that is the example I have to, but in networking the way is different. We'll create some VLANs. That is VLAN, it's a layer 2 protocol. Whenever we are creating VLAN 20 and whenever we are creating VLAN 30, those are the isolated by default. This is the class 10, you can assume. This is the class 8th or 9th, you can define. Both are isolated, though cannot communicate each other. So that is, we call it as a multicast. And broadcast means, so now switch, what it will be do, basically the PC1 send some information to PC2. So, so switch is a not much more intelligent device. So switch don't have any routing table and all. Switch maintain only CAM table, content addressable memory table, or CAM. Otherwise, you can MAC, media access control. These tables switch will maintain. I'll show you in lab. CAM, content addressable memory table. Otherwise, it will be maintained. We can call it as a MAC table also. Switch maintain two tables. So basically, switch have some intelligent device compared to hub. Hub unmanageable device, but in switch we can manage. We can change the configuration. Yesterday we discussed in lab. So I'll show you on later on sessions also. So now move to the concept. So this switch, what it will be do, PC1 send initiated some message to PC2. Hi. So PC initiated some message. Hi PC1, PC2, how are you? He initiated some message. So PC2 initiated when the switch received that message. Once the switch is received that message, what it will be do, switch, it will be do the broadcast the information. For him, PC2 also is sent, and PC3 we have, he sent to PC3 also, and he sent PC4 also. So switch, it's kind of device, it will be broadcast the information. It is a broadcast the information. So not required for that. So that is the reason we have a VLAN concept. Later on we'll discuss. So if we want to stop this broadcast, so it is kind of single broadcast domain. We'll stop that. We'll create multiple broadcast domains. So this is the concept of switch. Switch is a L2 device again. Switch is a L2 device. Apart from that, we have a L3 switches also. Those are the MLS multi-layer switches. The concept is different. But switch, it is kind of layer 2 device. Switch maintain cam table or mac table. So for that we have command show mac address table. So for that we can check that table, mac table. I'll show you in lab. So this is all about the switch, and switch works within a LAN. Switch work within a network. Switch will work within a LAN and within a network. Switch is work within the network. We'll discuss what is the subnet and all. It will work within a subnet. It won't cross the border in simple manner. So this is all about the switch. Now move to the router. And router is an intelligent device. Router will work in between a networks, in between two or more different networks. If I want to communicate this LAN to another LAN with help of WAN, wide area network. This is without WAN, we cannot communicate to different devices. We need a ISP. So if I want to communicate it to one geographical location to another geographical location, so we need a WAN connectivity in between, wide area network. So mostly if whenever you listen the WAN, so that time we'll use the router devices, routers, and router will maintain the routing table as well as MAC table also. And router having only one MAC address, entire router only one MAC address. But switch, how many interfaces having that many interface, that many ports? This is a port. This one is a port. Mostly switch having 24 ports switch we have and 48 ports switches we have in our network devices. But router having the limited ports. Routers having limited ports, because what it will be do, it's kind of major intelligent device. It will be if we want to communicate two different networks, it's a communication of two different networks. So that time we'll use a router, and within a LAN if we want to communicate, that time we will use switch. And switches having the more ports compared to router, and router will maintain routing table. That is the reason routing, it means it's a layer 3. It's a layer 3. Don't worry, we'll discuss what is layer 3, what is layer 2 functionality. We'll discuss each and everything, just devices. And we have a firewalls also in between. So it's firewall. So firewall. So before that, what we'll do, so here we'll discuss likewise fire. What is fire and what is wall? Everyone know what is wall? The goda. Likewise. And fire means everyone know Agni. So fire means what it will be do, it's kind of software will creating. So for that, it's a wall. It's kind of wall. It's a wall. So here it's kind of our inside network, that is LAN, and it's kind of outside network, outside. And one more we have network, that is DMZ. DMZ, demilitarized zone. DMZ zone. So it's a server, demilitarized zone. Actually, military persons established this network. So why they give the name demilitarized zone means, so before that, inside and outside, it's a LAN and it's a WAN. It's a fire and wall. It's a firewall where we are using our firewall. So inside and say outside. Before that, I'll tell you some story. So you have one friend and he's working in military. He's working in military. Military. He's working in defense. So you wants to meet to him. So inside defense, you cannot enter. This is a defense area. You cannot enter inside. So your friend also cannot permission to go outside. So for that, we have a one location. If you want to meet your friend, is a friend, your friend is working in military defense. You cannot, he's not getting the permission to, he's got the deny. The permission is denied to went outside. Don't go outside because we cannot trust outside people's. If you are give our confidential information to them, so it will be problem to us, they told. So you cannot go inside also. If you are going inside means simply they shoot. You cannot enter inside also. Simply they shoot, then you will die. Otherwise, the meeting is necessary now, the important meeting. So for that, we have a one zone that is not a, it's kind of one zone. There you can go easily and you can communicate to each other. That is, we call it as a demilitarized zone. So it's kind of entry, or it's kind of some reception, you can assume like. So it's kind of reception. So that is, we call it as a demilitarized zone. So, and we have a one website. This is our organization. Now coming to real time, this is our organization. We have one some multiple websites. So this is our local area network, LAN, and we have a entire devices we have here, and we cannot give the permission to access outside people's. Those can come inside means they can track our entire website or IP addressing entire thing. So we cannot give to permission to enter our land zone. Just will give to permission. Just if you want to communicate our websites. So we have a one website that is XYZ. So XYZ can everyone can access it. So for example, in real time, FB, Facebook, everyone have facebook.com account and Instagram account. Everyone have. Instagram company, they don't allow to come inside. They don't allow exactly. They won't allow also inside. So that is the reason that traffic outside, whichever the coming, they can communicate here, and whichever the information, FB, yes, you can log in and you can use that. If some bank website, we have access some limitations only, some bank websites on that. So those entire thing we can access and deny with this wall. So we are using some software for that. In this wall, in this firewall, we are using some software. So LAN users also come to here only, and WAN users also come to here only. They can communicate to each other. That is all about the firewall device. So mostly here we are allowing or denying the services, allow or permit the services, permit some services. So for that, we'll create some policies. So those are the zone based policies, zone based policy, inside zone or outside zone, DMZ zone. Those all are the zone based policies. So for that, we have a firewall part. We have a different vendors like Palo Alto and like Juniper, like FortiGate and Checkpoint. So these all are the different vendors, HP and Firepower. Firepower or ASA. This is a Cisco property, ASA or Firepower. Those are we have Firepower. So different vendors we have. And not even those firewalls, and Cisco switches also, and HP switches also we have Aruba switch. HP are nothing but Aruba only. Those are the devices we have. So firewall mostly have access at L2 layer deny or permit we can do the services, and we have L3 bases and L4 bases also we can access or deny the services. And in router, these are the majorly L3 device. Router is L3 device, and L2 it's nothing but it's kind of L2. So data link layer. So we'll now move. Any doubt in this? And we have a server also. Server. So server is a memory. We can use some our entire websites and all our storage we can store here. And apart from that, we have a access points. Access point again, it's a Wi-Fi wireless device. And apart from that, WLC wireless controller we have. We can control the access point information. We have if we have multiple access points, each and every device we cannot log in remotely. If we have a branch office, in this branch office we have a 50 access points. For this 50 access point, we can remotely access through WLC, wireless controller. These all are the network devices. This is all about the network devices. This is a network hierarchy design, 3-tier and 2-tier. And in core layer, we'll configure mostly routing protocols. And in distribution to this layer, we'll configure mostly switching protocols. And will redundancy part, we have taken here two devices. This is a redundancy. One device went down, we have another redundancy device. So that is the reason I have took two devices. If you have any questions, till what we
No, Alin,
discussed
it's
today.
clear.
Great.
It's clear
Thank
till
you.
now.
Fine. Now move to OSI model. Actually, OSI open system interconnection, and basically OSI it's a reference model. As we discuss, reference means human can understand easily step by step process. That is the reason it's a reference model. And one more we have here, TCP IP model. TCP IP model, transmission control protocol, and IP, internet protocol. We have two protocols. It's for understanding purpose. We are using here OSPF. It's a reference model actually. It's a reference means reference basis. A human can easily understand this model. So step by step process. Apart from that, we have a TCP IP model. It's implementation model. Here we have 7 layers. In this, we have 7 layers. And here we have 4 layers only. 4 layers. Only 4 layers. So in OSI model, we have first we will discuss application layer. It's not visible. Application layer and presentation layer, and we have session layer and transport layer, and network layer, then data link layer. We'll move to physical layer. So first, what is application layer? The application between whichever we are using in real time, whichever HTTP with you are using some applications. So user interacting, so user using some with basis of application, any applications comes under users. Those are the application layers. So before that, we'll discuss some little a bit about the OSI model. Then we'll move to the layer basis. So here you can check here. OSI was developed by IOS, International Organization for Standardization. So it's developed by the IOS and introduced around 1980. And it is a layer architecture consists of 7 layers, what we discussed, which define and explain how the communication happen in between two or more network devices within the organizations. So within the organizations, within the LAN or within one LAN to another LAN. So how the data communication is happen, that is, it will be explained. Each layer define a set of function data communications, and OSI stands for Open System Interconnection. It is just a model or language through which different vendor devices can do the communication with each other. So different devices are using HP, Aruba, Cisco. So those devices, so some different protocols they will use, but the model is same, the communication is same. So iOS, the model around 1984. So they started and they introduced. So this is our, and iOS is organized this OSI model, but TCP IP is DOD, Defense Organization, Defense of Organization. Defense of Organization, and it's a IOS, in International Organization for Standardization. It's kind of organization, IOS. ISO. So both are different. So first, internet is established defense organization only because they wants to communicate one PC. This defense. First, they established network. So likewise, they want to send some files through one PC to another PC. So then they started one couple of PCs. They started. Then they, why we are not introduce this to publicly? Then they started to announce it, and American defense it's announced it. American defense only introduced the first time internet. They only introduced this entire thing, this kind of things only, not iOS. So but iOS is given to reference model for understanding purpose. So now for, and we have later on, Apple also introduced Apple Talk, and Microsoft also introduced some OSI likewise model. This is a way which we can communicate to one PC to another PC, or one location to another location. They introduced this kind of models. Apple Talk also. No one are using the Apple Talk. Though most people are using the DoD only, TCP IP model only. And apart from that, ISO also using. And now move to the application layer. So application layer is a responsible for providing interface for the user to interact with application services or networking services, whichever the services. That is what, if we are using some Facebook application, so you are sitting here and you use some website FB, so directly you can reach to internet. But which application you are using? Through www World Wide Web. Before that, fb.com. fb.com. Before that, you can see here some HTTP. This is a service. This is the service. It will be used some port numbers. That is a networking port numbers. So that port numbers we can identify which service this user is using. Those are the, this is a service HTTP uses the port number is 80. And if you are using the S means it's a secure hypertext transfer protocol secure. So it will be used the different port number. So for this 443, so this is a port number through we can identify, network persons can identify the service, which service is using, which application is using. So every protocol having unique port numbers. Through that port numbers, we can identify the service which application user is using. Which application is using user. This is the application layer. Application layer is responsible for providing an interface for the user to interact with application services or network services. Which application services you are is using or which network service is using. So based on that, we have some protocol numbers to identify the service. So I'll give you some examples of protocol numbers here. So mostly we have a well-known port number, and so these are the port numbers. Every service having the different port numbers. Through this, we can identify the service. Through these port numbers, we have 2 to the power of 16. The range it will be 65535. So here we have the reserved ports. Reserved port means telnet having 23 and 22 SSH, and NTP having 123 and SMTP having 25. These all are the reserved ports. And we have unreserved ports. We can use the different manner whenever the reliability connection will be established in between. That time we'll use these port numbers. These all are the free of cost. You can use it. By default, the sessions will be generated. That time this port number will be used. So as we discussed, HTTP uses the 80 port number, and HTTPS is using the 443 port numbers, and DHCP, and every service, network service having the different and unique port number, that is reserved port numbers. That is reserved port number. These port numbers different service cannot use. If this port number same again different service is using, so you can assume like if the port number same here 80 instead of 23, then networking protocols, networking devices cannot understand, so they simply deny that services. So every service having unique port number, these are the only some examples. So we'll identify the application service through port number. This is all about the application layer. Now move to the presentation layer. So in this presentation layer, so in layer 6, it's a presentation layer. So presentation layer is responsible for defining a standard format of data, how the data flow is happen. This layer hold the responsibility to present the data in its actual format and users, and it deals with data presentation. The major function of describing at this layer are, so encoding the data, and the encoding means text format, whichever the text we are using, that is encoding. That is kind of JPG file, GIF file, or any graphic file. And apart from that, this is a voice file or something, wave or something. And these are the video files, data, AVI files. It will be identify the service. Presentation means present the data with identify the service, encoding and decoding. Encoding and decoding. It means I'll explain that what is encoding and decoding. Before that, so this is the encryption and decryption. This is the methods we have. Encrypt the data and decrypt the data. These all are the algorithms. DES, TDES, AES. These are the algorithm. And comprehension and decomprehension. I'll explain this. So for that, here we have one switch and here we have two PCs. This is a switch and this is a PC1 and it's a PC2. PC1 initiated some message to PC2. What he initiated? Hi, myself, PC1. He initiates some message. Hi, myself, PC1. He initiated some message. So, which kind of message? This is a text message. So, it's a encoding the information. So, whenever he's sending the before, encode the information and decode means it will be identify which service he's sending. So if it is voice, based on that, it will be encode and decode. And it will be apply some encryption and decryption. Encryption means X, Y, Z, likewise, based on whichever we are applying. So DES, apart from that, we have multiple. So these all are the algorithms. So encryption and decryption algorithms. Based on that, it will be encrypt and decrypt the data. Based on the encryption, so it will be how much bits you are applying. So 96 bits or 128 bits. So based on that, how that much it will be encrypted. If you are allowing 255 bits, so based on that, it will encrypt the data. So he initiated some message. Hi, myself, PC1. And likewise, comprehension, decomprehension means which service is using. For example, he sent via gmail.com. Via gmail.com, he sent this message. So whenever the receiver receive this information, so it's kind of sending and receiving. So I have taken only one switch, but if you can assume it's different geographical location, he sent PC2 is available in this different location. This is the different LAN and this is the different LAN. So once the data for here, it will be sending, that time it will be encoded. Once he will receive that information, it will be decoded. It will be decoded, and encryption and decryption also same thing. And comprehension and decomprehension means which service is using Gmail or Yahoo. Yahoo, if he's using Yahoo means Yahoo only will receive that information, not Gmail. Not Gmail will receive. That is the comprehension and decomprehension. Whichever service we are using, that service only accept that message. Different service cannot accept that message. In real time also, you are initiated message to your friend only receive that. Whichever you are giving the email ID, that email only it will be received. Based on this kind of presentation layer will work. So now move to the session layer. Session layer again, only the session layer work is here. Whichever you created the session, it's basically layer 5. It's a fifth layer. So whichever you create, initiated some session. Which session you initiated here? Gmail session you initiated here. Here you initiated the Gmail session. So the Gmail session you initiated, and that once receiver receive, the session will be established. After he received, PC1 initiated PC, this is a PC3. Now he initiated message for him. So till he receive that message, the session will be alive. The session will be alive. Once he received the message, hi myself PC1, once he received, the session will be closed. That is delete the session. The session will be maintained, the session will be delete, the session will be terminate, the session will be initiate, whichever the session layer responsibility is to maintain that session till receiver received that information. Once receiver receive that information, the session will be closed. That is the responsibility. In real time, I will give you one example. Whenever you are using the bank websites, they will provide you for limitation of time only. After the time period will be end, the session will be automatically closed. Means you cannot, if you want to check your balance, again you should have to log in. That is what we have a sessions in session layer. In real time, best example is bank website or something. And now move to the transport layer. So before that, some right here, session layer. So this layer will be responsible for initiate, maintain, and delete and stop the sessions. It will be initiating and maintaining and delete the sessions, session layer responsibilities. Now move to the transport layer. So up to layer 5, it's kind of applications layers. Application layer means those are all the software engineers will work. Now coming to transport layer, our work is started from here. Network engineer work is started from here. So we can identify the service of the application layer at this layer with the help of port numbers. So in top of the data, how it is coming. So whichever the initiated, so PC1 initiated some information, which service he is using. So here Gmail, definitely HTTP service, the port number is 80, the port number is 443, sorry, 443. So HTTP hypertext transfer protocol means it's a port number is 443 port number. So with this port number, the transport layer will be identified. Yeah, the port number is 443. Then the service is initiated. HTTP service, hypertext transfer protocol services. The PC1 initiated some traffic. So for whom the traffic he initiated, for PC2 he initiated. So my responsibility is to send in a proper way the traffic through identify the service. He identify the service and multiplexing and demultiplexing and segmentation and sequencing and reassembling, error correction, flow control, entire thing, the responsibilities here. And apart from that, the two major protocol work here, TCP, and apart from that we have UDP, transmission control protocol. This is the important protocols, guys. These are the important protocols. So TCP, transmission control protocol, and UDP, user datagram protocol. Will come back to this protocol. Before that, we'll finish identify the service. So through port number will identify, and multiplexing and demultiplexing means, so where he wants to send the multiplexing and demultiplexing, and segmentation with segmentation. So here he initiated some message, right? Hi, myself, PC1. So it will be segment the data. So hi, then it will be like PC1 and myself. The data whenever it will move, it will be the segment as segment, it will be move. It's kind of one segment. and this is a second segment, and this is a third segment. It will be initiated likewise. But this correction, who is doing? Once, see here, PC1, it's different location, and PC2, it's different location. So from first, it is coming from application, and user initiated some application HTTP and presentation and session, then transport. It will be identifies the service. He initiate this message to him. So once it will be received, he's sending likewise, and he received same application and presentation and session and transport. So that is what identify the service and segment, how segment will be happen. I myself PC1, likewise he will do. Once he receive here, I myself PC1, he received the information. He received, PC2 is received this information. So he how to give the reply, in this layer only it will be happen. That is what TCP and UDP will be provided that information. TCP, it's reliable protocol. Once he received that information, that PC1 sent information, he received that information. So error correction, flow control, if any error is there, so simply deny. If flow is happen likewise, the flow is flow control also, the layer 4 only doing here. So flow control. So whenever we are initiating the packets, it will be move likewise packets in network layer. We'll discuss packets in data link layer. That is frames. Data link layer frames, and physical layer we have bits. So in data link layer it will be frames, and here we have packets. It will be packet. So now move to the network layer. When network layer is coming, that is segmenter. We call it as a segment. Now, whenever the receiver send the information, it will be moved likewise only. Step by step, it will be moved. Now, again, I am explaining you here. Now, come down. Now, we'll discuss here. This is a PC1 initiated some message to PC2. So, hi, myself, PC1. So, first, through media, the data can flow. That is bit. Bit means 0, 1, 2, 0, 1, 0, 1. Machines understand 0, 1 language only. Machines can understand, media can understand 0, 1, 0, 1, 0, 1. This is the 0 means off. 1 means on. Bit is on. 0 means off. 1 means on. The media is using bit format. That is, we call it as a bit. This is the format, we call it as bit format. Binary format, can it will be initiated some message likewise. So this is, we call it as a bit. In which layer? It will be physical layer. It's a layer 1. He initiated some message. Once physical layer it is done, it will be moved to the, now move to data link layer. In data link layer, frames will be established. Initiated frames, the data will be moved like frames. So frames will, PC1 find out the exact MAC details of him, where it is available, on which he'll find out the MAC details. Through that, he'll send the frames, the information. So once he'll receive that, it will be convert to the packets. In layer 4, it will be convert to the packets. Then it will be convert to the segments. Anyway, we'll come back to and every layer by layer. Just I am explaining you, but here bits, frames, and packets. Likewise, it will be happen. And anyone have any queries up to here?
No, Lim.
Okay, fine. So we have two protocols as we discussed, TCP and UDP. TCP is a transmission control protocol and UDP is a user datagram protocol. So here we'll discuss TCP and UDP. Meanwhile, we'll discuss later on. So this is all about TCP. And difference we'll discuss UDP. Move to UDP. So TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. It uses the protocol number 6 and 17. It's uses the protocol number is 6 and it uses the protocol number is 17 to identify the service only. Again, we'll identify based on the which protocol we are using. So based on the protocol number, we'll identify the service. It is a connection oriented protocol and it is a connection less oriented protocol. It will be whenever the TCP, we'll discuss this thing, connection oriented and what is connection less oriented protocol, and it is reliable and it is unreliable protocol we'll discuss, and it is a slow processing and it will be fast processing compared to TCP. UDP is a fast protocol, fast, it's a faster protocol, it is a slower protocol, and the header size is TCP protocol is 20 and the header size is protocol 8 only. And in case of TCP retransmit of packet, it will be possible, but here not possible, that in this UDP not possible. And TCP checks the flow control of data. Here the flow, it will some protocols which follow UDP. So sorry, UDP doesn't check the flow, and some protocol which they follow, those are the protocols HTTP, HTTPS, Telnet. These are the examples. SSH and SMTP, and these are the example of DSCP, RIP, TFTP, SMTP, and here we have, and which browser it is using, emails and file transfer, and here online gaming, live broadcasting and calling, WhatsApp calling, this kind of best examples of that. And example of protocols here, which protocols are using HTTP, HTTPS, these are the protocols, and what is reliable and what is unreliable. So TCP mostly will use one three-way handshake. Whenever the establishing the data, it will be used three-way handshake. So three-way handshake means it's a server machine and it's a client machine. Again, this is a PC1, you can assume, as a PC2 you can assume, but it's a server machine and it's a client machine. Whenever server initiated some machine, some message initiated, his server initiated some message R1, you can assume R2. So he initiated some message, that is we call it as a sync message. Sync message. So he will give the reply with acknowledgement, ACK, plus sync packet, whichever he is sending, that is, and he will give the acknowledgement. This is a three-way handshake. This is called it as a three-way handshake. First, so whenever the TCP initiating or establishing the session, it will be established the session with reliable session, it will be established. But the whenever the UDP sending the packet, it will be, he don't worry bother about the his receiving or not, client is receiving or not, he will just initiate the message like this. He will initiate the message. You are receiving or not. He's simply saying words. You are listening or not. Simply he will tell. Some guys, lazy guys are we have. So those guys will tell those information, but we are listening or not listening. They don't bother about it. Just if they will tell that entire stories. Those are the UDP protocol will be used likewise, the best example. But in TCP he will bother about it. Once he is sending the information, he how to know the receiver is receiving or not. Source is a source and this is a destination. Destination is received that information or not. He will take care about entire thing. Once he will not receive, is denying, he will not send another packets. That is all about TCP and UDP. It will be work in transmission control protocol. It will be work in layer 4 presentation layer. Entire thing will be happen. Though whichever the networking protocols we have, best example BGP also reliable protocol, and here UDP, this is an unreliable protocol. Likewise we have, we'll discuss later on that. Likewise, up to here, any questions guys? Now move to the transport layer. So in this transport layer, mostly we have two types of protocols. One is routed protocol, another one is routing protocols. So now comes here, this is an important thing. What is the difference between routed and routing protocols? So listen properly. So here we have routed and routing protocols. Before that, we'll discuss what is layer 3. It is a responsible for end-to-end transportation of data across multiple networks. Basically, whenever you are initiating some messages, mostly if you want to communicate at branch 1 to branch 2, those are the different geographical location. So that time we need a layer 3 protocols. Those are the routers. What they will do, in between two different networks they will communicate. So logical address path determination routing are described at this layer. So here we'll use router means routing protocols, and the routers what it will be do, path determination, best path they will select. Entire thing we'll discuss later on. But here the protocol work at this network layer are routed and routing protocols. So routed protocols means the whichever IPv4 and IPv6, those are the protocols here we are using. IPv4 or IPv6, these all are the routed protocol. I will talk nowadays we are not using IPX. This is the IPX means IPv4 or IPv6. So I will talk we are not using that. That is what. And routed protocol act as data carries and define logical addressing. They will define the logical addressing through that. They will, so PC1 they will use mostly one IP address. Without IP address we cannot communicate. Every device having unique IP address, that is private or public, but every device having the unique IP address, then only we can communicate to each other. So IP addresses will work here. So here mostly apart from that we have a routing protocols also. Routing protocol, it means RIP, IGRP or EIGRP, OSPF, etc. Devices work at network layer or routers or MLS, multi-layer switches. So these all are about the network layer. Now move to the data link layer, and data link layer also. Here we have a two protocols will work mostly. Here also two protocols will work mostly. So those are the, so it is responsible for end-to-end delivery data between the devices, LAN network segment. So whenever we are using the LAN segment in switches, so here you can verify it, switches, bridges, NIC cards, those are the network data link layer. And the data link layer comprises of two sublayers. Here we have a MAC address controller, and we have a logical link controller. So logical link controller, it will be identify the network layer. So this layer will identify the network layer. So whenever just now we discussed, the data flow will be likewise. So L2, L3, likewise. So based on the LLC, we can find out which network, which IP address, which routing protocol we are using. Based on the LLC, we can find out. And access control. This is a MAC address. It's a 12-digit hexadecimal address, and it also provide error detection using cyclic redundancy routing and framing and all. And here we have the Ethernet token ring. This is a encapsulation method. Earlier we are using, but token ring, it's old, but Ethernet we are using nowadays. Ethernet means again connectivity in between, how we are connected to each other. Those are the Ethernet links and all. So through media access control, and as we discussed, switches having unique port MAC details of every port having one MAC address. Every port having MAC address. I will discuss those things in real time, our labs. I'll show you. And now move to the physical layer. The physical layer, it's a medium in between, whichever the copper media or fiber media, those are the media. Those are the media here. So deals with the physical transmission of binary data or given media, copper media, fiber media. It also deals with electrical and mechanical functional specification, devices media also. So electrical signals also. So those also. And now we are having the fiber optic cables. Those are the electrical, to convert it will be electrical signals only, fiber optic cables. So the major function of described this layer are, so this is the things. So these are the major functionals here. So encoding and decoding. So entire thing, fiber media and so sorry, copper media, fiber media, wireless media. These all are about the media of duplex or full duplex. And entire thing will be happen here. So this is all about the OSI model. Now coming to the TCP IP model. TCP IP model having the four layers only here. Quick overview. I'll finish it, the session. I'll give the quick overview. So here we have the four layers only. That is application layer, transport layer, and so entire process will be same. This is a layer 4 actually, which we are having the transport layer. That is a transport layer, layer 4 in OSI model. But here host to host also we call it as, or transport layer also we call it as this layer. So now move to the network layer and internet layer. It's a layer 2, and access layer means it's a layer 1. So it's a layer 2 and 3 in OSI model. It's a L3 as well as plus L2, whichever the functionality we discuss, same thing happen here. L2, same thing. And here UDP and TCP you can check here. This is a TCP as well as UDP protocols work here. Whichever the layer 4 functionality, entire thing will be happen here. And whichever the layer 1 functionality, entire media, something, fiber media, copper media, and wireless media modes of this entire thing will be happen in access layer. And application layer, it's layer 3 plus, sorry, layer 7 as well as layer 6 as well as layer 5. Thus this entire thing will be happening in this. That is why I call it as a software layer earlier. This is all about our OSI model devices. If you have any queries, ask me. I'll stop the recording.